Hello, today we will discuss sampling and sampling distributions, how to select a sample from a finite and infinite populations, point estimation, what is a point estimation, and a brief introduction to sampling distributions. And we will discuss the sampling distribution of the sample mean. What's an element? Element is the entity on which data are collected. Population is the collection of all the elements of interest. For example, if we are interested in the average apartment rent in Alabama, then every single apartment, we have to collect this information from every single apartment if we need to exactly calculate this average apartment rent. Then the population consists of every single apartment in Alabama. But since we cannot collect all that information, because if we need to exactly calculate the average apartment rent in the state of Alabama, we have to look at every single apartment in the state of Alabama, which this is not possible. So we need to select the subset of the population. Randomly select some apartments in Alabama. So what's the purpose of sampling? To answer a research question about a population. Since populations are large, due to some constraints, it can be some financial constraints, some human resource constraints, time constraints, we may not have access to every single elements in the population. That's why we select a sample, which is the subset of the population. But the sample results and collect, for example, you randomly select apartments from Alabama. This is the subset of the population, which is a sample. And the sample results are not the exact results. We can calculate the sample mean to estimate the population mean, but sample mean only provides the estimate. It's not an exact, doesn't provide the exact results. It only provides an estimate of the population characteristics. So if you would like to know the average apartment rent in Huntsville, you randomly select some apartments in Huntsville and calculate the sample average, and use that sample average to estimate the population average. And sample results provide only estimates of the values of the population characteristics. They are not the exact results, but with proper sampling methods, the sample results can provide good estimate of the population characteristics. Sampling. Now we will discuss how to select the sample. There are two different populations. You may have a finite population, or you may have infinite population, or you can consider that you have an infinite population. What's a finite population? You can have a list of all elements. For example, organization, membership, roster, credit card account numbers, inventory product numbers. You can obtain the list of all elements in the population. Then you can randomly select size n from a population of size n, which means that you can select a simple random sample of size n from a population of the n. What does simple random sample mean? Each possible sample of size n has the same probability of being selected. There are two different topics here: sampling with replacement and without replacement. If you replace an element before you select another element, that is sampling with replacement. And sampling without replacement, you don't replace that element before you select another element. That is sampling without replacement. Sampling without replacement is more commonly used if you have a large sampling project. Then you use random numbers, computer-generated random numbers. You usually use the computer-generated random numbers to automate the sampling selection process. Let's look at this example. Steve Andrews College received 900 applications from admission in the upcoming year from prospective students. The applicants were numbered from 1 to 900 as their applications arrived, and Director of Admissions would like to select a simple random sample of 30 applicants. So in this case, population is not large. It is actually only 900 population size. And we would like to select 30 out of 900. For a population size 900, actually not large, we can exactly calculate the results for the population. But the problem is you may not have all the applicants in the database. So in that case, you cannot, if you have short amount of time, then you may need to only look at the sample. If you don't have all the applicants on the database, all that information, and you may not have enough time to enter all that information into the database, then you can only select the sample, and you can calculate the sample statistics such as sample mean, sample standard deviation, and you can use the sample statistics to estimate the corresponding population characteristics. How do you randomly select 30 applicants? You can generate, using Excel's rand function, you can generate random numbers, and you can sort those random numbers, and you can either select the 30 smallest random numbers or 30 largest applicants that corresponding to the 30 smallest random numbers, or 30 largest random numbers. What's an infinite population? So you want to select a sample, but you may not have all list of all elements in the population. It may be an ongoing process, or for example, you would like to select average apartment rent in Huntsville. You would like to calculate the average apartment rent in Huntsville or in Alabama. You may not have a list of all apartments in the population. You may not have a list of all apartments in the state of Alabama. Or you may have an ongoing process. Consider a production process. It may be an ongoing process where there's no upper limit on the number of units that can be generated, such as transactions occurring at a bank, customers entering a store. These are considered infinite populations. You can't have a list of all elements of interest in the population. Then how can you select a random sample of size from an infinite population? You need to satisfy these conditions. What are those conditions? Each element selected comes from the population of interest. Each element is selected independently. Now let's look at this example. A common quality control application involves a production process where there is no limit on the number of elements that can be produced. For example, consider a production line designed to fill boxes of a breakfast cereal with a mean of 24 ounces of breakfast cereal per box. So samples of 12 boxes filled by this process are periodically selected by a quality control inspector to determine if the process is operating properly or perhaps a machine malfunction has caused the process to begin underfilling or overfilling the boxes. So we have a production line designed to fill boxes of cereal with a mean of 24 ounces of breakfast cereal per box. They inspect sample of 12 boxes. The quality control inspector selects sample of 12 boxes to see whether whether the process is operating properly or to see whether there is any machine malfunction. So how can we select the 12 boxes here randomly? So we have to satisfy these two conditions. Each element is selected independently. So since each box are filled independently, we satisfy this condition already. And now we have to satisfy this condition. Each element selected comes from the population of interest. And how can we satisfy this condition? We have to make sure that we select the boxes at the same point in time. So at the same point in time, this way the inspector avoids the possibility of selecting some boxes when the process is operating properly and the other boxes when the process is not operating properly and there is some underfilling and overfilling of the boxes. So what's the point estimation? We have two types of estimates, point and interval. Point estimation is a form of statistical inference, so interval estimation is a form of statistical inference too. We have two types of estimates, point and interval. Point, why it is point? Because it is a single number. You use the sample statistic, to estimate a corresponding population parameter. It is point because it is a single number. For example, we can calculate sample mean x bar to estimate the population mean. Mu population mean. Sample mean is just one single number. So we don't know how close that sample mean to the actual value of the population mean. That's why it is a point. It is just one single number. You can collect the sample, calculate the mean, but it is just one single number. So sample mean is a point estimator of the population mean. S is the sample standard deviation. We can use the sample standard deviation to estimate the population standard deviation. Sigma is population standard deviation. We can calculate sample standard deviation to estimate the population standard deviation. So sample standard deviation is the point estimator of the population standard deviation. It is point because it is just one single number. And we don't know how close that sample standard deviation to the actual value of the population standard deviation. Or sample, P bar is sample proportion. We can use sample proportion to estimate the P, which is the population proportion. Sample proportion, if population proportion is unknown, we can calculate the sample proportion. Sample statistics, they can serve as they're only estimates of the population, corresponding population parameters. Sample mean, you can use, if population mean is unknown, you can calculate the sample mean to estimate the population mean. For example, you need to know the population mean, but it is unknown, and you may have an infinite population, or you may have so many elements in the population. You may not have enough time to collect all that information for every single element. You may not have enough resources, time, money. So in that case, or you may not have enough human resources to do all those, to collect all that information. So in that case, you can randomly select a subset of the population and use that sample, and you can calculate the sample mean and use a sample mean to estimate the population mean. But sample mean is just one single number, and we don't know how close that sample mean to the true value of the population mean. That's why we also have interval estimates. But in order to develop an interval estimate, we need to know the sampling. For example, if you need to develop an interval estimate for population mean, then you need to know, you need to develop a sampling distribution of X bar. Same thing for the sigma and p. If you need to develop an interval estimate for population standard deviation, then you need to know the sampling distribution of S. Or you need an interval estimate for population proportion, then you need to know the sampling distribution of P bar. And we will briefly discuss the sampling distribution and sampling distribution of X bar. Now recall that Steve Andrews College received 900 applications from prospective students. An application form contains a variety of information, including the individual's SAT score, whether or not the individual desires on-campus housing, So the meeting in a few hours, Director of Admissions would like to announce the average SAT score and the proportion of applicants that want to live on campus for a population of 900 applicants. So 900, as we said, it's not large for a population size. But now they have meeting in few hours and they have to announce the average SAT score, proportion of applicants that want to live on campus for 900 applicants. And the necessary data on the applicants have not yet been entered in the college's computerized database. So the director decides to estimate the values of the population parameters of interest based on the sample statistics, because they only have few hours and they are not on the computerized database. And the sample of 30 applicants is selected using the computer-generated random numbers. And these are the sample results based on those 30 applicants. Sample mean is 1,684, sample standard deviation, and the sample proportion that wants to live on campus. And remember, the different random numbers, like you can select the different applicants, will give different results. So you can select another 30 applicant, you will get a whole, you will get different results. So how many different ways can you select 30 applicants out of 900, how many different ways? Combination, which is a lot. It's a big number. So different sample will give different results. Different sample of size 30 will give different results. This is just one sample of size 30. But now, okay, assume we enter all the data, and now we calculated the exact results. So this is the exact mean. This is the population mean. And this is the population standard deviation, and exactly 72% wants to live on campus housing, So now we compare, we can, in this case, since we calculated the exact results, population parameters, like population mean, population standard deviation, and population proportion, we can compare our sample results with this population parameter value. So we estimated this population mean as 1684, which is actually very close because actual value is 1697. And we estimated this 87 population standard deviation 87.4, the estimated value 85.2, which is actually very close. And in this case, we estimated this population proportion is 67%, which is very close in this case. With good sampling methods, we can get actually good estimates. So, the process of the statistical inference, so assume the population mean, some population parameter is unknown. You select the sample to make estimates or inferences about that corresponding population parameter. It doesn't have to be just one parameter, it can be multiple parameters. That summarizes that process of statistical inference. Now we will discuss the sampling. We will discuss sampling distribution of X bar. So remember, we said we have two types of estimates, point and interval. So point estimates, like sample mean, is the point estimator of population mean, which is one single number. We also calculate the interval estimates, which provides entire of possible values. The purpose of the interval estimate is because the sample point estimate is just one single number and doesn't provide any information about how close that sample mean is to the value of the population mean. That's why we also calculate the interval estimates. And in order to calculate the interval estimates, we need to know the sampling distribution of the corresponding statistics. Like if you wish to calculate the interval estimate of population mean, then we need to know the sampling distribution of X bar. What is sampling distribution of X bar? Which is a probability distribution of all possible values of the sample mean. So you calculate one sample, that is just one sample. But you can calculate many different, such as in this case, even in this case, population size is only 900. We select a sample of size 30. They provided this result, sample mean of 1684. But how many different ways can you select sample of size 30 out of 900? Which is a lot. We can calculate that combination 900 choose 30 is 10 to the 55, which is 9.8 times 10 to the 55. It's a big number, and different samples will give different results. So the sampling distribution of X bar is the probability distribution of all possible values of the sample mean. And what do we need to know about the sampling distribution of x bar? We need to know the mean of x bar. All this can be proven, but the proof is not the scope of this course. Sampling expected value of x bar, which is mean of x bar, equals the population mean. And this is actually this is called an unbiased estimator. If the expected value of point estimator equals to the population parameter, we say that the point estimator is unbiased. So sample mean is an unbiased estimator of the population mean. So expected value of x bar equals population mean of x bar. How about the standard deviation of x bar? Standard deviation of x bar equals sigma over square root of n for most cases. For almost all cases, it is equal to sigma over square root of n. This is for the finite population, but if you look at this number, since populations are lot larger than the sample sizes, this number close to the approaches the 1. For example, in our case, n is 900. And actually, n is, for the population size, 900 is not large. But even that, what is this number? This is almost 1. Square root of this. So it's almost 1, close to the 1. So if you multiply something with 1, you get that such as sigma over square root of n times 1 is sigma over square root of n. And here actually, if n over n less than equal to 0.05, a finite population is treated as being infinite. Like 30 over 900 is 0.033, which is less than 0.05. So it's treated as being infinite. So actually, you need to know this one, which is standard deviation of x bar, which is also called standard error. What is a standard error? Which is sigma x bar is standard error of the mean, which is a standard deviation of the point estimate. Sigma x bar equals sigma over square root of n. So now we need to know the mean of x bar equals the population mean. Sigma x bar equals sigma over square root of n. And now the shape of the sampling distribution. We need to also know the shape of the sampling distribution. So if we are sampling from a normal distribution, if population has a normal distribution, then the sampling distribution of x bar is normally distributed for any sample size. But in most cases, the sampling distribution of x bar can be approximated by a normal distribution, whenever the sample size is 30 or more. But if you are sampling from a normal distribution, the sampling distribution of x bar, regardless of the sample size, is normally distributed. What is the sampling distribution? What is the purpose? Since sample mean is just one single number, we don't know how close is sample mean to the value of the population parameter. Sampling distribution of x bar can be used to provide a probability information about how close the sample mean to the population mean. And the central limit theorem helps us to identify the shape of the sampling distribution of x bar. So we are selecting sample of size n from a population. The sampling distribution of sample mean can be approximated by a normal distribution as the sample size becomes large due to central limit theorem. So if we are sampling from a normal distribution, if the population is a normal distribution, then sampling distribution of x bar, sample mean, is normally distributed regardless of the sample size. But we may not know the population distribution, or population may not have a normal distribution. Population may have some other distribution. Then how do we know the shape of the sampling distribution of x bar? In that case, we use the central limit theorem, which helps us identify the shape of the sampling distribution of x bar. What does the sampling central limit theorem says? If the sample size large enough, then the sampling distribution of x bar is approximated by a normal distribution. And how large? Usually, if sample size is 30 or more, it is enough for normal approximation. But if your population is really skewed, like exponential, then you need to increase the sample size. But for most applications, the 30 is good enough for the normal approximation. So to summarize, what do we know about sampling distribution of x bar? The mean of x bar equals the population mean. Actually, this should be here, center, not here. Mean equals to population mean. Standard deviation equals to sigma, which is population standard deviation, divided by square root of n. And if the sample size is large enough, then the sampling distribution of x bar is approximately normally distributed. I hope this makes sense. If not, please let me know if you have any questions.